Hello friends, in this video I'm going to expand this function in this interval in Fourier series. So before that, for better understanding, please click the link given in the description box. There is a video, okay? Please do watch that video first, okay? So now let me explain how to solve this. So here you see the given function f of x is equal to nothing but x, right? And the interval is here, the given interval is x is greater than -1 less than +1, and in this case when you have interval in this form l x greater than l minus l less than l instead of plus pi and minus pi, then how to find that Fourier series? So first we need to find the value of a naught. So formula to calculate the value of a naught is 1 by L integration from minus L to plus L, right? Minus L to plus L f of x dx. Then we have to find an, okay, which is equal to 1 by L integration minus L to plus L, right? So f of x cos n pi x by L dx, and bn is equal to 1 by L integration minus L to plus L f of x sin n pi x by L into dx. That's what we need to do. And Fourier series is given by this f of x is equal to a naught by 2 plus summation, right, from n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. That's what that is the series actually, okay? So first let me obtain these three values, okay? a1 b1 a naught an bn, okay? So first let me take a new slide, okay? And first let me obtain a naught, okay? Let me copy this and let me take a new slide. So function is f of x is equal to x, right? So we are to find a naught is equal to, so here L is nothing but 1 because the interval is x is greater than -1 and less than +1. So this is nothing but minus L, right? This is minus L to plus L. That means in this case -1 to +1, right? So here you see -1 to +1 integration f of x is nothing but x dx. So if you integrate x, then you're gonna have 1 by 1 is simply 1, so it is not necessary to write here. So -1 plus 1, okay, if we integrate x dx, then we should get x square by 2. So here is the limit -1 to +1, right? Now let's put the upper and lower limit. If you put +1 instead of x, so +1 square divided by 2 minus, put the lower limit -1 whole square by 2, so both gonna give you half minus half, that's gonna be equal to 0. So we have got a naught is equal to 0. Now let me obtain an. So what was the formula to obtain the an? So let me copy this formula and let me go to the next slide. So here we're gonna obtain an. So how to obtain an? Now you see here 1 by L instead of L we're gonna put 1 integration -1 to +1, then f of x is x here. In this case f of x is nothing but x, so let me write it properly, x, then cos of n pi x by L dx. So hope you have the idea of even function and odd function. So now you see x is odd function and cos is even function. So what is even function and odd function? Now you see, suppose you have a function f of x. If for both plus 1 and minus 1, if the value of f of x, that means f of plus 1 and f of minus 1, in both cases their values of this function are equal, for x equal to plus 1 and minus 1, then it's gonna be even function. Otherwise, if it is not, if these two are not equal, then that's gonna be odd function, right? So we know that cos of minus theta and plus theta, or cos of plus x or cos of minus x, both equal to cos x, right? So that's why this cos x is even function. And when the function f of x is equal to x, if you put plus 1, then it's gonna give you 1, and if you put minus 1, then it's gonna give you minus 1. So this is odd function. So product of odd function and even function, that's gonna give you odd function. So when you integrate an odd function over an interval minus a to plus a, then it always gonna give you 0, right? That's always gonna give you 0. So without integrating, we can write here directly 0, because here we can say that since x is odd function and cos n pi x by l is even function, and their product is odd function. So that's why we have got 0 here. Now let me obtain bn, value of bn. Now let me go to the new slide to obtain this value. First let me copy the formula. This is the formula to calculate bn. So let me copy this formula bn. So here you see, this is the new slide. So here the function f of x is nothing but x, interval is minus 1 to plus 1, right? Minus 1 to plus 1. So minus 1 means minus l, and plus 1 means here plus l, right? That's it. Hope you have understood this. So now let's put l is equal to 1. So 1 by 1 integration minus 1 to plus 1, right? Minus 1 to plus 1. F of x is nothing but x, sine of n pi x by l dx. Now sine function is odd function and x is also odd function. Product of two odd function is even function. Okay, and we can obtain such kind of integral in this way. You can write this integral in this way: 2 into, from instead of writing minus 1 to plus 1, you can write 0 to 1. Okay, when you multiply 2, okay, then x sine of n pi x by l dx. Okay, that's what we have got. So now let me clean these things. Okay, let me divide the piece. So again here we're gonna apply u into v rule. U into v, integration of u into v dx, that is equal to u integration of v dx minus integration derivative of u integration of v and whole dx here, right? Hope you have understood this. So we're going to apply this value now. So let me first integrate this function, then we're going to put the value, upper limit and lower limit. First let me integrate only. Let me find the integration only. X sine n pi x by l dx. So here x is to be considered as u and this part is considered as v. So if that is the case, then we're going to find, first we're going to write x integration of sine n pi x by l, that's going to be minus cos, integration of sine is minus cos n pi x by sorry, here I have to put 1 instead of L, we are putting 1, so simply we can write sine n pi x, right? So sine n pi x, if you integrate sine n pi x, then you're gonna have minus cos n pi x by n pi, right? That's what you're gonna have. Okay, after integration we have got this, right? Then minus derivative of x is nothing but 1, derivative of x is nothing but 1. Okay, then integration of sine n pi x is again minus cos n pi x by n pi, okay, dx, right? So now here we have got minus x cos n pi x divided by n pi, then here minus minus plus, again if you integrate it, integration of cos, that's going to be sine n pi x by now n pi square, n square pi square, that's what we're going to have. Okay, so now we are integrating it from now you see bn is equal to 1 by n l, 1 by l is 1 here, so 1 by 1, that's simply 1. So we are integrating it from 0 to 1, right? We are integrating it from 0 to 1. So here that's going to be sorry, so I have missed that 2, so let me write this way. Okay, so here I have done only the integration part, so bn is equal to 2 into, so this is nothing but this is the value, this part, integration of this, right? So we can write let me write this one here, sorry. Okay, so we are integrating it 0 to 1, right? Now let me copy this step and let me go to a new slide. Okay, so here is the last step we have got. So now you see, let's put the upper and lower limit. Now let me tell you, sine n pi, that's always going to be equal to 0, so this part is definitely going to be 0. So now here if we put the upper limit here and here, then we're going to get minus 1 cos n pi, instead of x we are putting 1, so we're going to have cos n pi divided by n pi plus, sorry, not plus, minus. Now put the again lower limit, so here we're going to put 0 instead of x, minus 0 into cos n pi 0, so obviously this part going to be equal to 0, 0 into anything is 0, so we end up getting this only. So now you see 2, and we know that cos n pi is nothing but minus 1 to the power n, so minus into minus 1 to the power n by n pi. Now you see, if you multiply this minus 1 with this minus 1 to the power n, then it's gonna give you 2 into minus 1 whole to the power n plus 1 by n pi. That's what we're gonna have, right? So now you see, let me go back to the equation number 1. Where is the equation number 1? This one. So as we have got that a naught, value of a naught is equal to 0, value of an is also equal to 0, so we have we end up getting the summation of this part only. So therefore let me copy this equation number 1, let me copy this equation number 1 and let me write here. Here you see, this is equation number 1. Now let me write the values of a and b n. So an is equal to, we have got 0, and a naught is also equal to, we have got 0, right? We have got a naught, a n both equal to 0, right? Here you can see this is a naught which is equal to 0, and this is a naught, a n which is also equal to 0. So only we are getting bn, so let me copy this bn. So this is bn, right? So value of bn is this is the value of bn, right? So now if we put this value here, then, and f of x is nothing but this x, this function x, right? So therefore we're gonna have summation from n is equal to 1 to infinity, instead of bn we're gonna get 2 minus 1 to the power n plus 1. We're gonna write this constant part outside here, divided by n pi sine n pi x by, instead of L you can write 1. Okay, instead of L you can write n pi x. That's going to be the answer. So hope you have understood this. So if you want to expand this series, putting n is equal to 1 2 3, then also you can expand. If you put n is equal to 1, then 2, if you put n is equal to 1 here, that's going to be 2 by pi, and putting 1 here, that's going to be plus 1, and sine pi x, because n is 1 now, right? So now in the next term, if you put 2, n is equal to 2 here, so that's going to be minus 1 to the power 3, that's going to be negative 1. So in that case, minus 2, this n is also 2, so 2 pi, then sine 2 pi x, then again positive 2 by 3 pi, 2 by 3 pi, then sine 3 pi x, then again minus, and dot dot dot, so on. This is the answer. So hope you have understood this. Thank you for watching. See you in the next video. Bye bye.